Disco Ladyada.
Hey everybody, it's Ladyada Clock. It's our cool new retro graphics, thanks to Bruce Yan, who gave us a little bit of a...
Nature's healing. We're starting to be able to think about
fresh
things
look.
besides staying alive.
Yeah.
So
like some retro graphics.
We have some retro graphics.
Thank
so
you.
We'll be introducing some more fun surprises, new look of Disco Ladyada.
I like this look.
As we recover.
Very CGA. We've got some retro themed things on the menu today.
Right.
First up, maybe I could show off this. I'll maybe quickly show off this PiBasic thing.
Yeah, let's go.
So on the we did a little one minute video. Hold on, let me go to my thing. I think was it load factorial dot basic, and then run, and then you can see there you go. Okay, now you can see the text, so we can make factorial of I don't know, 23, very large number. So this is something that you saw on Hackaday you sent over. It's a basic interpreter written in pure Python. And one of the neat things about stuff that's written in pure Python is that CircuitPython tries as much as possible to be a pure subset of CPython. And so I just actually copied the files over, and it's you can run a Python interpreter in it. So you can let me actually go to the PiBasic repo, because they have a listing that you can run. So in the REPL, like the Python REPL, the basic REPL, you can put in your favorite basic scripts. I'm just going to copy this one at a time. And what's funny is that CircuitPython comes from MicroPython, right? It's a fork of MicroPython, and MicroPython was clearly inspired by Arduino, and Arduino was inspired by PiBasic. So it's kind of like we're gone full circle now, where the stuff we're inspired by is now running emulated on our hardware. Oh, sorry, it's confused because it's like, why did you have two things? It's like, why are you running two scripts at the same time? But yeah, so you can run it. It will output text here underneath my head over here. It's neat to see an interpreted language interpret another language. Now, there is a limited amount of RAM, so like some of the bigger projects like Eliza, it would have been cool if it could run, but it takes up so much RAM that at least this. It's funny, I should have tried on ESP32S2. That actually probably would have been able to run PiBasic and run a big script. So maybe I'll try that next time. I was thinking like, what has the most RAM? And it's like the RP2040 with 256K. But actually the ESP32S2 has the most because it has 2 megabytes of PS RAM. It's a little slow, but it's basic, so who cares? Anyways, it's a fun thing. You can go download PiBasic from the repo, check out the Hackaday link, and then just drag and drop the files on, and yeah, it's upset. But drag and drop the files onto your board. In this case, I got a PyPortal, but you can run on anything, and then you can run your favorite basic sketches. I don't know, kind of cool. Very retro.
All right, what else you got going on?
In style. The other thing I've got going on is Jepler this week wrote a library for another camera. So we started with the OV5640 classic camera. Then we updated to the OV. So the 7670 I think maxed out at 640 by 480 resolution. Then we went to the OV2640. The 2640 I think was a 2 megapixel, maybe a 3 megapixel resolution. And I think this is the 5640, which I believe is a 5 megapixel resolution. It's like 2.6 K by 1.4 K. It's like 2,000 pixels by 1,400 pixels. Of course, this is a video of a camera, of an overhead of a TFT of a camera, so it doesn't look. It looks kind of washed out, but it actually looks quite good on the the display itself. So you can see, you know, my hand here. One thing you can see is it does auto contrast. Sorry, auto what is it? Brightness. So, you know, like when I first, you know, it kind of washed out, and then it kind of realizes like, oh, I'm washed out, and it reduces
Cool.
the DC bias to the, you know, the CMOS sensor, and so, you know, it's dark and then it gets light, and so it tries to do its best to auto levels the image, which is really nice. So I'm trying out this camera module that I got. Now it's got a 120 degree fisheye lens, which is not bad. I mean, it's a fine lens, and it comes with a little lens cap. There's even one I got that you can, this little part here can actually twist. This has a little bit of glue on it, which is not unusual, so it's kind of fixed. It's a fixed focus, and the focus is kind of like infinite focus, so it's not good with nearby stuff, but it's good for, you know, basically anything a foot or farther away. There's an autofocus version that you can, a focusable version where this isn't glued, and you can twist the camera lens. I also I got some other samples. So these are OV5640s. So I really like the higher resolution and a lot of the features of the 5640, especially the auto. The color looks much better, to be honest, than the 2640 or the 7670. So I also got like this. There's kind of different lenses, right? So this is a 2640 with a with a kind of like a simple lens, and it doesn't turn at all. It's also kind of got infinite focus lens. And then the one that I thought was interesting is this camera. So this is a 5640, although I couldn't get it working. But it says 5640 on it, so I believe it's 5640. But what's interesting about this is it's got this kind of like metal body, and I didn't understand what this was. And then I realized that, you know, when looking at the spec sheet, that this is actually, the 5640 has the ability to do autofocus. And so when I opened up the body, so you can see there's the CMOS sensor, nice big sensor over there, rectangular. And then over here you can see the jewel lens. It's very, very pretty. And then, let's see if I can remove this. Not so gently, because it's already been destroyed. But you see here that this is
the... move that so you can see it under the overhead.
Yeah, it's tough to...
There you go.
There you go. So you can see the lens, and around it is a voice coil. So this is a coil of wire. And this can very slightly move the lens above and below the CMOS sensor. So this is actually a micro motor, basically, like a little miniature motor. It's actually kind of neat because the sensor itself apparently has the ability to control the motor and automatically do the autofocusing. The only thing is I couldn't get this, well, obviously this one's destroyed, but this camera module, I couldn't quite get it to be recognized. There's something going on. It's not being powered, or like it has some weird requirements. I checked the pinout on my computer. So this is the, this is what the normal module pinout looks like. And I'll move this over here. So no, let's see, can maybe, hold on. Yeah, okay, so it's kind of legible. Okay, so there's the camera and there's these pinouts, and then at the bottom you see pins 23 and 24 are no connect, and this is the non-autofocus. This is like the camera module that I showed earlier, the 120. And then when you look at the version with the voice coil support, you can, first off, you can sort of see there's a little bit of a coil looking thing here in the middle. But they also this is a focus range. So it can focus from 10 centimeters plus, and it's got those two pins are AF VDD and AF ground. So that's the autofocus, ground, and power. So it looks like you just have to power the autofocus system, and the camera will kind of take it from there. It controls the motor, and maybe even I think it automatically does all the work for you. You just sort of have to tell it to go into that mode, which makes sense. Like for a lot of low cost, phones, they'll use a camera like this for the camera phone, and you don't necessarily want the camera processor to be like doing the autofocus management. You want the camera to kind of do it on its own. How it actually does it, I don't know. I guess it looks for blurry pixels and then like just tries to reduce the blurriness. I guess it's got like a DSP. It has a DSP anyways because it's got to do JPEG encoding. Maybe that DSP can also do autofocus. I'd like to get that working, so hopefully by next week I'll have autofocus functionality. Anyways, that's my camera experimentation. Yeah, I've never seen anyone actually use these autofocus cameras, so we'll be the first. Like right. people have them, but I've never seen anyone successfully use them.
Okay, but I'll do some bit of notes, and then we'll do the great search.
Yeah.
Check out our updates on adabox.com because we hope it'll get to you by Halloween. But just spin the dial on the TV, and you'll see there's a global part shortage. There is a shipping crisis, and
there's no flights.
That's domestic. And then
we need the flights to come in.
Yeah. And then in China, they're operating the factories 3 days a week.
Yeah.
And 4 days closed because of electricity rationing. And not only if you're waiting for parts from China, you're going to be waiting even longer, and you're going to get half of them. And to go ahead and answer the question, even if someone already knows, there are things that are just not made in the U.S. In fact, it is terrible. We should make transistors and all sorts of stuff here in the U.S. We don't. And so, go try to find a bicycle tire made in the U.S. Maybe there's a place, maybe not.
No, yeah. Not made in the U.S.
Yeah, and so we're all stuck with this together. And so it's just part of the post-pandemic. I mean, it's not over, but we're all just trying to make the pandemic not the lead story. So keep checking adabox.com. You can also ask anytime. And then just another note, I'll probably talk about this on Ask an Engineer. Our team's 100% vaccinated.
Yay!
We didn't need to threaten them with like taking away health care or fines or this or that. Everyone has great health care. So what they did is if they had questions, they talked to their doctor. And their doctor said, hey, it's a good idea for you to get vaccinated. And so we're done, but we have some last formalization of it. And then in New York, there's a HEROES Act. And we've already completed that, which is to make sure our team has all the information about everything you need. So that's just me telling everyone who either you work at a company or you're someone who helps run a company, it is possible to have over 100 plus people all do the thing that keeps each other safe. I think to get trust, you have to give trust, and that is how we did it. So you want to do the great search?
Yeah, let's get right to it.
Okay, so I'm going to add the song back later. But for now, it's
the great search.
Yeah, beep, beep, beeper, 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 beeper. Yeah, we'll probably do a retro version. Okay.
Okay.
Great search brought to you by Digi-Key and Adafruit every single week. Ladyada uses her powers of engineering to find stuff on Digi-Key.com. We're going to be talking about the 5.5 timer this week. Ladyada, what is a 5.5 timer?
A 555, also known as a triple nickel, is a special chip that kind of was invented, I think, in like '76 or so. It's a all-in-one non-microcontroller chip that can be used for timing purposes or oscillator purposes. It can do a delayed time. It can do a repetitive, like PWM type cycle. It can change duty cycle of a PWM. It's really good for if you don't want to get a microcontroller involved. You just want a frequency generated or a pulse generated. It's great. It's really easy to use, and there's like thousands of example circuits. And we thought with the retro styling, and also because we have a video from Colin that came out this week, I was like, I should show people how you can get 555s. And also, 555s have really improved in capabilities. Like they're not as clunky and power hungry as they used to be. They're actually quite cool and easy to use in wide voltage ranges and very low current draws.
And if you're a super fan, You've seen our puppet and our cartoon character, and also our plushie. We named the 55 timer Hans after the inventor of the 55 timer chip. We don't have any of these more left, but that's some of the things that we've done over the years. I also have a 555 timer stool from Evil Mad Scientist Laboratories that I bought, and then Hans is one of the puppets in the Circuit Playground kit series. And then last week, Colin did a 555 timer video, so I thought I'd play that, and then we'll jump into the search on Digi-Key.
Sure.
Why is the 555 timer one of the best known ICs of all time? Well, it's been around a long time, and there's a crazy amount of example circuits out there for it. It's also cheap, easy to use, and most of all, versatile. A 555 timer can be used as a timer, performing a single action after a specific period of time. An oscillator, generating a repeating waveform at a specific frequency. A PWM signal generator, outputting a waveform of varying pulse width for controlling servo motors, LEDs, etc. Plus less practical uses, like using two of them together to create a stepped tone generator, aka Atari Punk console. For a modern update to the 555, consider the TLC 551. It's pin compatible with the original, has a wider input voltage, and higher accuracy.
Okay, so let's kick it off. You want to find these?
Yeah, so 555 timers, they've been making them for decades and decades. They're still useful all the time. Like, we use them in our Dradio kits, but we also see them a lot of times in learning to solder, learning to engineer, because they're a great way to make a simple circuit that you don't have to worry about software or firmware being the issue. So many things have been replaced with microcontrollers, but then you have to deal with microcontroller programming and like bootloaders and firmware and computer and toolchain. 555, it just always works, and they're like rock solid. They're really hard to damage. I've never seen a broken 555. They always seem to work as long as you're using them with the ranges that they function at. So going to the computer, I'll close this up. Okay, so the NE555 is like the original classic, and you can still get it if you happen to need like one of the originals. Let's say we want the dip package. Oh, they're not in stock, but let's see. Sorry, dip. Any of these? Yes. No? No, they're not in stock because they're obsolete. But it looks like Rochester usually has them, but they're out of stock right now. The original could run up to about 100 kilohertz. Ran from about 4.5 to 16 volts and drew 10 milliamps. So, that's good TTL logic, voltages and current. You need a lot of voltage, you need a lot of current to use electronics. You can run off of 5 volts, but you really need 5 volts. You can't run it lower. That said, oscillators have improved quite a bit in the meantime. So if we just look we'll just go to clock timing, programmable oscillators, and then these are all the 555s. Oh, you don't forget, you can get dual 555s if you ever need two 555 circuits, like Atari Punk consoles. I think usually you have one for frequency and one for like duty cycle or something. So you'd have 2 oscillators. So it is possible to get 2-for-1s. Let's look at only ones that are in stock and available at Digi-Key. Thankfully, you can get 555s. You can't get a lot of chips, but hey, you can even get them in
This is all we get.
VGA.
You have to build everything out
You
of 555s.
can build everything out of 555s. Okay,
Yeah.
so let's look at 8 dip. Because I think a lot of people, when they're first playing with 555s, just on a breadboard, they want to breadboard their circuit. So let's also only look at active ones, so you can not get anything that's not available. So here's something, the first thing that's interesting. So, the original was 4.5 to 16 volts, or 18 volts. But chances are you want to be able to run off of a couple batteries. And so, we can select a range that's, you can run it off of 1 or 3 volts up to 15. So that's kind of nice. There's also different frequency ranges. So, you can get ones originally that was 100 kilohertz. We can see they go up to megahertz now. And then the supply current is in the microamp range. So you can actually run these off of a battery. Now, there are different, there's a lot of different ones. Like the TLC 551 that we used in the Dradio has a special 100 milliamp output. So you can actually use it to drive a small speaker. Or I think maybe it's a 10 milliamp output, so you can drive a transistor to a speaker. To check there's some kind of there's been interesting mods and hacks and tweaks to the 555 to increase the output current or decrease the runtime current. So do check that out if you have special needs. But if you just want a simple 555 that's in stock, TLC 555 will do the job. Looks like these are available. There's 2,000 of them or so. And this one can run from 3 to 15 volts, draws 360 microamps and up to 2.1 megahertz in through hole. And it's, less than $1 in quantity. It's 40 cents. So that's the thing. These are really cheap too. If you are doing, workshop or you want to teach people electronics or you want to mess around and you don't want to spend a lot of money, a 555, you can build projects for a year on 555s. And you won't spend more than $10 on it. So check this out. You might also want to get a parts pack from Adafruit with resistors and a breadboard. Put that together with the 555, and you can be having a really good time. Even a couple potentiometers. You can make blinking circuits, buzzers.
I guess it's
it's
available somewhere. I wrote an article when I was senior editor of Popular Science, like almost 15 years ago now, maybe more. And what I did is I cracked open a digital camera, and I had it so the button would press over and over, and I put the camera on a kite, and I showed how to take photos from a kite, because we didn't have drones back then that you could just get easily. And I flew this digital camera up in the air, and I took a bunch of photos, and I showed how to do it. And I had to make it fit all on a printed page.
I remember that. It's like a perfect example. It's like how to replace a signal that
I just wanted
goes
to go burp, burp, burp,
every
burp,
10
burp,
seconds.
Yeah.
It pulses. Yes, could use a microcontroller, sure, but a lot of people don't have it. This and big cap and 2 or 3 resistors, and you're done. That's
it might be on Google Scholar or something, or wherever they scan in Popular Science.
Do you want me to look it up?
No,
the maker.
No. And then at Make, when we launched the first issue, we did aerial kite photography.
Yes, I think that was it. Was that my article in Make?
No, that was.
What was my article?
In the first Make one.
Yeah.
I don't remember. Maybe about.
No, I'm gonna find out.
Maybe it was about
Aerial.
wave bubble. I don't know.
Kite.
All right. Well, let's end the great search now.
Yeah.
So we can do other stuff. Okay. So that is a great search. I'm getting a song later. Okay.
I'm curious about what Aerial is spelled with an A-E.
Yeah. All right. You want to do a couple questions and then we're going to bounce?
Yeah. But I'm curious. I did write an article for Make. I just don't remember what it was.
Yeah. I have a copy in somewhere in here. Okay.
Yeah.
Question for later. Now is later. How do you manage the nightmare of breadboard jumpers? What do you use? DuPont cables?
Yeah, I mean, I quickly, actually using, those premium jumpers are really nice, but you really do want to go quickly to custom cut little jumpers, and you can lay them flat against the breadboard. Okay, here it was. I did write an article on aerial kite photography. Yeah, this is my 555 timer. You want to go to my computer?
Yeah.
I knew I did this. I didn't publish this on Make, but this is still on Ladyada.net. So this was...
That's interesting that, you know what? I didn't know you...
I don't think you wrote that. I think you read my article.
No, I didn't.
I used to hack disposable cameras a lot.
I think, that's funny, because I don't think we had met. No, we didn't meet. So what's funny is it looks like you did a 555 timer for a digital camera thing on Instructables.
Yeah.
I don't. Instructables wasn't.
No, it wasn't Destructible. It's on my site.
I was gonna say because Instructables wasn't around.
Yeah.
That's cool.
Well,
I'm gonna check the dates. I'm gonna check the dates later. I think we both independently.
I think everyone did the
we
same
all yeah we were
thing.
all like because digital cameras finally became like okay, who cares if it crashes into the water?
Everyone was
It wasn't
doing the
like
same.
$400.
Same
It
thing.
was
This is what
they were
I
getting
know.
cheaper and cheaper and cheaper.
Yeah.
I used a I think it was an Olympus digital camera, and it had it wasn't an SD card, and it wasn't an
Okay.
MMC card. It was another type
It
of
was
card.
by Charles Benton.
Yeah. Hey, look, that's me.
That's you.
I wrote about the
You wrote about this.
yeah. So how long ago was that? Go scroll up.
Oh, I remember what it was. This had a mechanical thing, and I was like, "Oh my god, that's nuts!"
Yeah, it did. It
And that's why I was
and it was a
like-
disposable digital camera.
Yeah,
Can
and
you
I was-
scroll up and see what date it is on that?
2007.
2007. Okay, yeah, that's when we were doing. That's when I was doing Meg. Okay.
Yeah, and I remember I read it, and I was like, "Wow, that's like so messed up that you would use." That you would use a mechanical system, and I was like, oh, we should just do an electrical system. And I'd been taking apart disposable cameras, so I knew that it was really easy to activate them because I made an art project where I like set off a bunch of disposable cameras. Disposable digital cameras, by the way, were like the coolest fucking thing. Like they were so cool.
Yeah. Remember what was the thing that Cisco bought and they didn't do anything with it? It was the digital cameras that we all hacked. It was It was a digital camera, and then Cisco bought it for like a ton of money, and nothing came out of it. It was like something cam. Anyways, I don't know. So anywho,
Looks like everyone had the same idea. It was like you
let's
put a
do a question.
Yeah, one more question.
Do you think U.S. produced chips could be cost effective enough to compete with versions of China that are suffering from shortages and shipping issues?
Well, the cost of making a chip is not labor. There's almost no humans actually involved in making chips. It's completely automated. So it's mostly about whether, the government wants to subsidize. Also, chips are not made in China. They're made in Taiwan. I don't know that there's that many fabs in China. Maybe there's like one or two.
Yeah, it all depends.
But right now,
it all depends what it is.
All chips are being made in Taiwan. We do have a fab, I think, in Texas or Arizona.
Yeah, I mean, my opinion about this is I think we all need to become a global, others-focused society that cares about one another and figure out ways to interact together in better ways than we are. Because obviously we rely on all parts of the world to live the type of lives we want to live. So we have to figure this out. And we didn't do a good job during the pandemic. Maybe this will be a good reason to think about how we can do things better together. Because I think we're way behind schedule on the United Federation of Planets thing. If there's other planets out there and they're making cool stuff, we don't even have it together to interact with them yet. We don't.
I know.
We got to get on that. Okay. I think that is everything we got tonight.
Okay, so I should have 555. I did have a 555 circuit to show with the.
Yeah, it's funny. I'll look later to see. It was flip. It was a flip camera, and Cisco bought them, and then where did it go?
Yeah.
Who knows? GoPro came out. All these things. So, anyways. Okay.
All right.
That is
That's it.
Desk of Ladyada tonight. We'll
Thanks,
see everybody
everybody.
next week. No, this is cool. It's time. Or 5-5 timer.